Good morning all. I Salim, Assistant Professor in Kite Group of Institutions, presenting you Voltage Controlled Oscillator, also abbreviated as VCO. A voltage controlled oscillator is an electronic oscillator whose oscillation frequency is controlled by a voltage input. The applied input voltage determines the instantaneous oscillation frequency. Consequently, a VCO can be used for frequency modulation or phase modulation by applying a modulating signal to the control input. A VCO is also an integral part of a phase lock loop PLL. Our next topic. A voltage to frequency converter VFC is a special type of voltage controlled oscillator designed to be very linear in frequency control over a wide range of input control voltages. So here is a oscillator. Here is the diagram. We have a DC input. In oscillator we have components like RLC, resistor, capacitor, inductor. When we apply DC input to a oscillator, we get a output like this. It is a AC and it has a frequency. Now if in conventional oscillators, to change the oscillator frequency, it is required to tune the passive component like resistor and the capacitor. Means these component R and C. If I want different frequency from this oscillator, then I have to change the value of R and change the value of C, and according to this R and C I get a different frequency from this oscillator. In voltage controlled oscillator we have controlled voltage. Means it is a oscillator whose frequency can be controlled using the external control voltage, not by the tuned component like R and C. Here we control the voltage directly, not the value of resistor or capacitor. In voltage control oscillator with a given set of passive components, just by changing the control voltage, the output oscillation frequency can be changed. Means for a given RLC component, by changing the value of input voltage, we change the frequency of output. Here is the block diagram of voltage control oscillator. We have a microcontroller to change the voltage level, and then we have a DAC, digital to analog converter. Then we have controlled voltage over there. Then this controlled voltage is given to VCO. Then we have variable frequency. In the next diagram we have a graph of variable frequency with control voltage. As the control voltage increases, frequency also increases. Here is a direct relation, and here is the relation of F out, frequency out, output frequency of voltage controlled oscillator is equal to F naught, which is my nominal frequency, plus K is my tuning gain, and Vc is my control voltage. Here are the types of voltage control oscillator. There are two types: harmonic oscillators and relaxation oscillators. Harmonic oscillators generally generates sinusoidal signals. Means its output is always sinusoidal. But in relaxation oscillators we generate square wave, triangular wave, sawtooth wave signals also. Here are the some applications of variable controlled oscillator. The voltage controlled oscillator. First, phase lock loop. Second, modulation and demodulation circuit. Third, frequency synthesizers. Fourth, function generators. This is all about voltage controlled oscillator. Thank you.